All right, here's the first part of the Chapter 6 review. The first one is a graphing an exponential function. So your regular exponential function looks just like this. Goes through 1 there on the y-axis, has an asymptote on the left, so it doesn't go below the x-axis. And now all you have to do is shift this graph. That +3 means left 3. Because it's part of the function that's left and right. The -3 means down 3. So you're going to shift it from this point, the point that we know. Move that point left 3, 1, 2, 3, and then down 3, 1, 2, 3. So you're right here at -3, -2, and redraw the graph. Make sure on the left that asymptote is still there. So it's like 1 below that point. It just curves up there and grows quickly, exponential growth. And there's your graph. The next one, number 2, is a logarithm graph. So the logarithm graphs are the inverses of the exponential graphs. So they look like reflections along the line y equals x, that diagonal line. It looks like this. So instead of going through 0, 1, it goes through 1, 0. And instead of growing really, really fast, it grows really, really slow. So now that's your base graph for a logarithm. The +5, it's just like the +3 on the exponent. That means left 5. The -2 is going to mean down 2. So you take that point at 1, 0, go left 5, 1, 2, 3, 4, 5, down 2, right here. Now just redraw that graph. Now this also has an asymptote just like this graph, but this is a vertical asymptote. So make sure you start not more than 1 over from that point and really just redraw the graph. Now remember, this is a non-calculator part, so make sure you know what these graphs look like. Now we're going to evaluate a logarithm, again without a calculator. This is, we set it equal to x, and then we change it into a log, so 10 to the x. We change it to a base. 10 to the x equals 1,000. So you get the same base. So this is just like an exponential equation now. 1,000 is 10 to the third, basically, because there's 3 zeros. So now that you have the same base, you can just set the exponents equal to each other, and there you go. Log base 10 of 1,000 does equal 3. Number 4 is the same type of question. Set it equal to x, change it to an exponential equation. So we have 8 to the x equals 1 over 4. The common base here is 2. So 8 is 2 to the third. We still have that x there. 4 is 2 to the second. Now we have to get them to the same level. So 2 to the 3x. You can bring this 2 to the second up, make it 2 to the negative second. So now we just set the exponents equal to each other because we have the same base. 3x equals -2. Divide by 3, and it's that easy. So the log base 8 of 1/4 equals a -2/3. Next question, we have some equations to solve. First one's an exponential equation that you can get the same base to. So it's just like, it essentially is just like the ones above it. So we're going to look for the same base, and this one, like the one before, has the same base of 2. So we already have that base there. 8 is 2 to the third. Get them on the same level. And now we're going to set the exponents equal to each other. And let's see, we're going to subtract 4. And then finally divide by 3. So x equals negative 7 over 3. The next one is problem number 6. It's a logarithm equation. Now there's a log on both sides and there's nothing to condense. There's only one log. So we're just going to change this into a exponential equation. Again, it's just like the problems above it. You just go 3 to this side to the third equals this. So 3 to the third equals 4x plus 5. So 3 to the third is 27. So we have 4x plus 5 equals 27. We're going to subtract 5. And then we're going to divide by 4. 2 goes into both of those, so I'm going to reduce it to 11 over 2. So that's the first page of the review. And we'll do the second page in a separate video. So stay tuned for that.